Okay, so let's do some more examples. The first one we're going to do is we're going to write it as a single fraction, and the second one is going to be a little bit harder, but we're going to actually simplify it all the way through to show you that it actually comes out to be really nice. So the first thing we do is try to write everything factored, but it already is. So we could go ahead and skip that first step. The second step, right, was to write out the LCD. So the LCD told us to write all the different terms in the bottom. So W and 2W minus 3. Those are the only things that are different there, but the highest exponent of each of them. So the highest exponent of this W here is either 1 or 2, so clearly 2 is bigger. And 2W minus 3 is the only one there, so that's the highest exponent. This is the LCD, not with a single W, but a W squared. So again, ask yourself, what are you missing in the first one in the denominator? So I'm missing this 2W minus 3. So that's what I can multiply to the top and the bottom. This one though, I have a W there, but not a W squared. So if I were to expand this out, really it's W times 2W minus 3. So here I have this portion, but I'm missing this single W. So I need to multiply the top and bottom by W. So let's go ahead and write all of that out underneath. Which is going to be 2W minus 3 times W plus 2 divided by 2W minus 3 W squared. And remember, if you're adding and they have the same denominator, you can add the top and keep the bottom. So I'm just going to go ahead and do that. Because we have 2W squared. So this is what we end up getting when we write it as a single fraction. Now, you can do all of this distribution and see if the top is factorable, and then maybe you might be able to cancel some things. That would be simplifying it all the way to the end. But what you really should be doing is looking at the instructions to make sure that you solve the problem according to what the question is asking. So what it wanted us to do was write as one fraction. So we got these two fractions here and wrote it as a single fraction. So did we answer the question or not? The answer is yes. So once we get to here, we're done. That's it. This one, however, what I'm going to do is I'm going to write simplify completely. So what I want to do is take this thing and simplify it as much as I can. Now, I'm probably going to need this board to do it. So factor, right? Step one is factor. So the first one is done. The second one is done. But the third one can be factored, right? The numerator can be written. So let's go ahead and do 48. It's going to be 48, 1, 12, and 4, 6, 8, and 6 times 2, 3 times 2. Okay, so we went through this entire list, and I can't find something which adds or subtracts to get to this negative 11m. So it's not factorable. So we can leave the top, the numerator as is. So let's try to factor the bottom. Let's try 3, 2, 4, and 1. 8 plus 4 minus 1. So this gives you 12, backwards. Plus 4 minus 1. So this gives you 8 minus 3, which is 5. Step 2, write out the LCD. The LCD is given by each of the items in the denominators that are unique. And the highest exponent of each of these is 1. So this is the LCD. What is missing in the first one is the 3m plus 4. And what's missing in the second one is the 2m minus 1. And nothing is missing in the last one. It actually has everything already. So let's go ahead and write all of this out. So it's going to be m plus 1. And I'll write all the factors out. Times 3m plus 4. Then we're going to subtract out 2m. And then this one right here is going to be multiplied by 2m minus 1. And then we're going to leave the rest, which is plus 4m squared minus 11m minus 12. And the denominator is the LCD, which is 2, write down that. m minus 1 and 3m plus 4. So right now, this is where we would stop, right? If we just want to write it as a single fraction. So what we're going to do instead is we're going to do all of this arithmetic and see if we can simplify it even more. So from here, that first part, the part with the blue, if I do the multiplication, it's going to be 3m squared plus 4m plus 3m plus 4. The green part is going to be minus 4m squared plus 2m. And then the black part I'll keep the same. This entire thing is going to be divided by 3m plus 4, 2m minus 1. Now, you might be asking why we didn't do the bottom part and expand it out. The reason for that is because we still want to try to cancel things, right? So we cannot write this thing as a multiplication because we don't know how to do it, right? It's too ugly. So what we're going to do is we're going to write it out and we're going to expand it, simplify it as much as we can, and then see if we can factor it. So let's go ahead and simplify this part. Here's a square, there's a square, there's a square. The green one and the black one cancel, so you're just left with 3m squared. The m's are right there. So that's 4, 5, 6, 7, 8, 9, 11 minus 9, 9 minus 11 is going to be minus 2m. And then lastly, the 4 and the 12, the negative 12 are left. So that's going to give us minus 8. All divided by 3m plus 4 times 2m minus 1. So now let's go ahead and try to factor that numerator, which is going to be something times something. There's 3 in the front, and we can get 4 and 2, which is going to be minus 2 plus 4. Negative 6 plus 4 gives you a negative 2. And this is all divided by 3m plus 4 times 2m minus 1. Okay. So notice that if you actually simplified it, there is some sort of cancellation, right? It's these two. Now, lastly, the last thing that you need to do is remember, when you cancel things in a division, you need to figure out where the restrictions happen, where the division by 0. So you need to solve 3m minus plus 4 is 0, or m is equal to negative 4 over 3. So this is the restriction, and it still needs to go there. So m cannot be negative 4 over 3. This is the simplified version this sum and difference of rational